My name is Joseph Haymaker. I'm a new PhD student under Dr. Reiter in the Crop and Soil Environmental Sciences program at Virginia Tech, and I'm going to talk about cover crops' impact on corn yields on our long-term cover crop study at the Eastern Shore AREC, and I will be presenting some of the data from Dr. Bethany Walter's dissertation research, who worked on this project prior to me, as well as some of the preliminary data I've collected so far this year. Some of the overall soil health problems we face in our region is that we have sandy soils with low organic matter, face problems with nutrient leaching, and hard pans. Cover crops offer potential solutions to all these soil health problems and many more, such as preventing erosion, scavenging excess nutrients, and fixing nitrogen, as well as relieving soil compaction, increasing water infiltration and water holding capacity, and increasing soil organic matter. Cover crops can be broken into three main groups: grasses like rye, sorghum, Sudan grass, and triticale, which produce high biomass, scavenge nutrients, and have a high seed-to-N ratio; legumes like clover, hairy vetch, and cowpea, which can fixate nitrogen and have a low seed-to-N ratio; brassicas like radish, rapeseed, which have deep tap roots and can break up compaction and scavenge nutrients; and then you have your mixes, which can be multiple species of any of these groups, variable biomass and accumulation and seed-to-N ratios, and are designed to fulfill specific functions. So for our study, we have 12 different treatments of various crop and cover crop rotations. This is a chart of our rotations of our study, which is now in its 6th year, and I'm now going to go into some detail about what each of the treatments are. So treatment 1 is an all corn conventional tillage system with no cover crop. We're considering this our baseline A, and this is our only conventionally tilled treatment, and every other treatment from here on out is no-till. Treatment 2 is an all corn no-till system with no cover crop, and this is our baseline A-till. Treatment 3 is an all corn grass cover crop, which is cereal rye. It's a high seed-to-N ratio, and the cereal rye is planted at 115 pounds to the acre. Treatment 4 is an all corn legume cover crop, which is hairy vetch, which has a low seed-to-N ratio, and hairy vetch was planted at 23 pounds to the acre. And treatment 5 is the last of our all corn treatments. It's a diverse cover crop, which we refer to as the kitchen sink, and it has a mid seed-to-N ratio. And the kitchen sink consisted of 9 different species of various grasses, brassicas, and legumes, as you can see listed here on the chart. Treatment 6 was a corn full season soybean rotation with no cover crop, and this was our baseline B. Treatment 7 is the same rotation as treatment 6, but now we're adding a vetch rye cover crop every winter, and the vetch and rye were planted at the same 115 pounds and 23 pounds to the acre rates as they were in treatments 3 and 4 respectively. Treatment 8 is a corn wheat double crop soybean rotation with no cover crop. This is our baseline C, and this is a typically implemented rotation in many agronomic productions. Treatment 9 has various purposeful mixes that are implemented over winter and during summer too, after the soybean wheat rotation. We refer to treatment 9 as a diverse mix 1, and here's what the various mixes are in it and what their rates and seed-to-N ratios are. Treatment 10 has various purposeful mixes as well that are implemented over winter, but this time the summer cover crop mix is during summer 1, and there's also no wheat grown in this rotation. And we refer to treatment 10 as our diverse mix 2, and once again here's what the various mixes are and what their rates and seed-to-N ratios are. Treatment 11 also has various purposeful mixes that are implemented over winter, but also have cover crops implemented over both summer 1 and summer 2, and only winter 1 and summer 3 have cash crops, which are wheat and corn respectively. And we refer to treatment 11 as our diverse mix 3, which once again here are what the various mixes are and what their rates and seed-to-N ratios are. And lastly, treatment 12 has a long-term perennial mix, which is made up of clover, alfalfa, and orchard grass, and then corn is grown in summer 3. During summer year 3, which was in 2017 and currently ongoing this year, all treatments were planted in corn, and 55 pounds per acre of starter nitrogen fertilizer was applied at planting. Then prior to side dressing, the main plots were divided into 4 subplots, and 4 different nitrogen rates were applied at side dress, which were 0, 50, 100, and 150 pounds per acre, and randomized throughout each plot. The following 2017 data was collected and the graphs were created by Dr. Walters for her dissertation research. This graph shows the 2017 corn yield data of the different treatments and the different fertilizer rates. You can see that the treatments that had a low seed-to-N ratio cover crop prior to corn were some of the highest yielding corn, which would be treatment 4, 7, and 9. This slide shows the corn yield response to the different nitrogen rates, and the important takeaway is that treatments 4, 7, 9, and 12 do not have significant differences between the 4 side dressing rates, which means that there is no additional yield benefit to side dressing on these treatments. Now, when comparing the 2017 corn yield data, at both 0 and 150 pounds per acre rate, the cover crop treatments had significantly higher yields compared to the non-cover crop treatment. Then, comparing the rye cover crop versus the mixes were significantly higher yielding than the rye at 0 pounds per acre, but not at 150 pounds per acre. Meanwhile, the vetch cover crop was higher yielding than the mixes at both 0 and 150 pounds per acre rate. Now I'm going to show some of the preliminary data that I've collected so far this year. Here shows the average height of the corn at the different growth stages for each treatment, as well as the NDVI readings for the V5, V7 growth stage. And also, like to note that the V5, V7 growth stage was when the plots were divided into their subplots and side dressed. Now at the V11, V13 growth stage, you can really see the differences in the different treatments, and the heights kind of match up with the yield data from 2017, and this trend will continue with the other data in the next few slides. And here at the VTR2 stage, you can see that the controlled treatments are all shorter than the cover crop treatments, but especially in the continuous corn treatments of 1 and 2, with the conventional till being the shortest. At the R3, R5 stage, SPAD readings were taken, and you can clearly see the difference in side dressing rates and how the treatments that had a low C/N ratio cover crop prior to corn have less difference between the different fertilizer rates, which is similar to 2017 yield data. And here was a neat picture I took of a nice edge effect on the border row of the corn soybean no-till control, which is treatment 6, from the hairy vetch on treatment 4, which had creeped out into the alley between the plots, and the border row was significantly taller from the extra nitrogen available from the vetch. So in conclusion, corn yield is greatly impacted by the use of cover crops, especially when following a low C/N cover crop. The preliminary data collected so far in 2020 appears to potentially correlate nicely with the 2017 yield data. And I would also like to note that there are many other benefits to the uses of cover crops that are being analyzed in this study, such as conserving soil moisture, increasing soil organic matter, scavenging excess nutrients, fixating nitrogen, relieving soil compaction, and increasing infiltration, just to name a few. But for this talk, I just focused on the corn yield response data. And now I'd like to acknowledge the following: the USDA NRCS Conservation Innovation Grant Program, Southern SARE, Virginia Tech Eastern Shore AREC, and the Virginia Tech Crop and Soil Environmental Sciences Program. And if you have any questions or comments, feel free to contact either myself or Dr. Reiter at any time, and I will leave the contact information in the description below. And also feel free to follow us on Facebook to keep up to date with some of our ongoing research. Thank you.